All right, everybody, here is the second video to get you ready for your final exam. So I'm going to quickly go over some questions that might have been a little bit tricky or ones that involve maybe an explanation or maybe involve certain equations, and I'll show you how to solve them. Let's start with number 17. Not necessarily an equation, but just wanted you guys to think about this. So an asteroid is falling towards the Earth at a speed of 10 kilometers per second. What types of energy are related to the asteroid? Explain your answer. So there's a couple of things that we could say. I mean, there's the two off the bat is related to the speed of the object or the velocity of the object, right? So any object that's moving has kinetic energy. So that's the first one. So I'd say kinetic energy, kinetic energy. And then if it's above the ground, there must be some gravity that is pulling on it, and so that would be related to potential energy, right? Anything above the ground, anything affected by the gravity of the Earth has some potential energy. So, if I have my asteroid here, some of you are better drawing than me, have better drawing skills than me, and here's our Earth. Well, it obviously has some kinetic energy because it's moving this way, and then it has some potential energy because it's above the Earth's surface. All right. And might imagine that you could even list thermal energy. That's kind of a bonus one because anything that enters our atmosphere is going to heat up. And so there is some thermal energy there. And maybe you can think of some other ones, but those are the first that come to my mind. All right. Let's talk about 18. There's a pendulum and it's swinging back and forth. Um, and so, you pull it all the way back to here and then you let it swing and it swings and it swings and eventually you catch it right here at this moment. And at that moment, it has a certain amount of potential energy, a certain amount of kinetic energy, um, and a certain amount of thermal energy. And the question is, well, how much thermal energy does it have? The key idea of this question, which is in bold, is use the law of conservation of energy. And that law says that the total energy of a system should not change, right? Energy cannot be created and it cannot be destroyed. So at moment one, our total, our total is 8.5 at moment one. And if energy can't be created and it can't be destroyed, then at moment two or at any other moment, our energy should be 8.5. All right, so that basically means that these three numbers should add up to equal 8.5. All right, so 1.8 plus 1.8 plus something equals 8.5. So what we can do is we can say, all right, well, I know these two added together is 3.6 plus, let's just say x, just to put some variable in there, equals 8.5. All right. And maybe you can already see what the correct answer is, but if we subtracted 3.6 from both sides, we end up with x is equal to 8.5 minus 3.6. All right, and that means that our x variable here is 4.9. Now, energy is measured in joules. So I can say that the thermal energy, let's put TE for thermal energy here. Thermal energy is equal to 4.9 joules. All right, maybe even a harder question here is this one. This might be the hardest question on the whole set because it takes some math skills and it takes some thinking here. The object in the previous question has a mass of 0.4 kilograms. Find the velocity of the object at moment 2. Given the equation for kinetic energy is Ke equals 1/2 mv squared. All right, so we know we're looking for the velocity. We know the mass. We know the kinetic energy. It's actually right here. Kinetic energy is 1.8. So we know that the kinetic energy is 1.8. And those are the only variables in the equation, Ke, m, v. So let's plug in our numbers, do a little bit of math, and we'll figure out what the velocity is. Now, just to kind of put this into perspective, right, this thing is swinging back and forth. So here, for a split second, it has a velocity of 0. And then as it starts to move, it has some kinetic energy. And then down here, it'll have the most kinetic energy. So it has some kinetic energy here, and it is moving. So we're going to try to figure out what is that velocity right here as it's swinging down. So let's see, we have KE equals 1/2 mv squared. Well, this is 1.8. The mass is 0.4 mv squared. All right, 1.8 equals 0.2 v squared, right? 1/2 of 0.4 is 0.2. All right, now I have this v squared and I have 0.2. Let's get rid of the 0.2 first. If this is multiplication, then to get rid of that 0.2, I needed to divide both sides by 0.2. So divide both sides by 0.2. All right, I'm just going to move over here where I have more space. So now I have v squared is equal to 9.0. And then the last tricky part, this isn't my final answer. I have v squared. I want to know what v is. What is my velocity? So a lot of times, like I've mentioned before, to get rid of something, you have to do the opposite function, right? To get rid of something multiplied, you have to divide. To get rid of a square, you have to take the square root. So those two things cancel out, and I end up with an answer of 3.0. The square root of 9 is 3. All right, I'm just going to do 2 more problems here, 27 and 28. All right, we have a small light bulb, has a resistance, it requires a certain amount of amps. How much voltage do you need from your battery to turn the light bulb on? All right, so there's a very simple relationship here. We have V, I, we have R. All right, it's asking for voltage. The resistance of 9 ohms. Resistance is 9. And amps. Amps is a measurement of current. So like how fast are the electrons kind of flowing through your circuit. So this is 0.35. So the pretty simple relationship here is V equals IR. So I can plug in these numbers. V equals 0.35 times 9. And that would be 3.15 volts, right? So if you have some batteries, you would need, a couple of batteries here. If you're trying to turn this light bulb on, you would need maybe 3 AA batteries would do the job, but that's your answer there. All right, last one. The average toaster uses 1100 watts of power from a 120 volt socket. Find the current flowing and the resistance of the okay. So first thing I'm seeing is watts, and it also tells you what those units are for. The units are for power. So my power is 1,100 watts. And it tells me my voltage too. So V equals 120 volts. And so it wants 2 things. We want the current and we want the resistance. All right, well, the current is the easiest one to find because there's another pretty simple relationship, which is P equals IV. So the power of an electronic is the current times the voltage. So I'm going to go 1100 equals I times 120. All right, divide both sides by 120. And so I is going to be 1100 divided by 120. So that would be 9.16 amps. All right, now that I know my current, I can find my resistance using the relationship of V equals IR. I know my voltage is 120, and now I know my current. My current is 9.16. So now I can find R. I'm going to divide both sides by 9.16. And that should give me 120 divided by 9.16. So the resistance is 13.1 ohms, and the symbol is that is like this omega symbol, or you could just write ohms. Okay. All right, and that's it. I'll stop here. Those are some of the questions that I wanted to go over to get you ready for the final exam. All right, good luck.